Good afternoon, everyone. Today we'll be looking at general solution for trigonometrical function, grade 12 CAPS syllabus. So the first thing I would like to explain is this part written in blue. This part simply states that if you have a general solution expression that has a sine 2a and a cos 2a, remember the double angle identity of sine 2a is only 1. It does not change, but for cos 2a we have 3. So if you have an expression which has a sine 2a and a cos 2a, change that cos 2a into this the double angle identity. And then if you have a constant in that general solution given to you, try to make sure that you use this trigonometrical identity. Try to change that constant into this trigonometrical identity. And then if you in your expression you have a sine a and a cos 2a, change that cos 2a into this double angle identity. And then if in your expression you have a cos a and a cos 2a, change that cos 2a into this trigonometrical double angle identity. And then after that you'll have to expand and factorize. So here's an example here. Let's look at this example. The example says I must find the general solution of this expression. The expression is 2 cos squared a minus sine 2a minus 1 is equals to 0. So what do we have here? I have a sine 2a and I also have a cos 2a squared. You see? So since I have a sine 2a and a cos 2a, sorry, this is cos 2a. So since I have a sine 2a and a cos 2a, it means that I should apply this rule. So I should change my cos 2a into this double angle identity, which is what I did here. And then minus 2 sine a cos a, because the double angle identity for sine 2a is only 1. It does not change. And then I also have a constant, is this one. If you have a constant, what are you supposed to do? You're supposed to change it into this trigonometrical identity. I did that here. And then from there then on, you simply multiply out your brackets and then you simplify your things. When you simplify your things, you arrive at this step here where you can see is cos 2a minus 3 sine a minus 2 sine a cos a is equals to 0. This thing here is a trinomial. So you can do what? You can factorize it. So when you factorize this thing, you'll get a cos a minus 3 sine a and cos a plus sine a. All is equals to 0. So now you have two parts. You have this part is equals to 0 and that part is equals to 0. So separate them into two. You come this side. This side you have cos a is equals to 3 sine a. Taken from cos a minus 3 sine a is equals to 0. Therefore, you know that sine over a cos will give us a tan, and since the angle is the same, it simply means that this thing is just tan a is equals to 1 over 3. But then, since you can see here is what is tan a. Tan is positive in which quadrant? In the first quadrant and the third quadrant. So you'll have to divide it into two again, the first quadrant and the third quadrant. So my reference angle A is what is simply shift tan 1 over 3. On your calculator you'll get 18.43 degrees. That's my reference angle. And then in quadrant 1, the answer is just going to be that reference angle, which is 18.43 degrees plus k 180 degrees. Why? Because the period of a tan graph is only 180 degrees, with k obviously being an element of an integer. And then on a third quadrant, remember is 180 plus theta, or 180 plus your reference angle. My reference angle is what? Is 18.43 degrees. So it's 180 plus 18.43 degrees, which I get 198.43 degrees plus k 180 degrees, with k being the element of an integer. So I already have one part of this trigonometrical solution. So let's come to the other side. The other side is taken from this cos a plus sine a is equals to 0. So cos a is equals to minus sine a. So it simply means that we'll have a tan a is equals to a minus 1. But to get to reference angle, remember that we do not put negative numbers when we are using trigonometrical function in a calculator, because it's going to be undefined. So all we do is that we note this negative number, which means that the solution are going to be where the tan graph is what? It's negative. Tan is negative in the second and the fourth quadrant. So your reference angle will simply be shift tan 1, and then you'll get 45 degrees. So in the second quadrant, we know that is 180 minus the reference angle. So it's going to be 180 minus our reference angle is 45 plus k 180 degrees. Therefore, our general solution is going to be 135 degrees plus k 180 degrees, with k being the element of an integer. And then in the fourth quadrant, we have a is equals to 360 minus the reference angle. So it's going to be 360 minus 45, which will give us 315 degrees plus k 180 degrees, with k being an element of an integer. So let's look at the other example. The second example says that I must find the general solution to sine 2x is equals to tan 28 degrees. So what I'll suggest you do here, find your tan 28 degrees in your calculator, and then I think you'll find that is 1.53, right? And then this side you still have your sine 2x, right? And then if it's like this, you leave your 2x here, and then here you find your shift tan into 0.53, and then you'll get that your 2x, it's 32.12 degrees, which is also your reference angle. And then now you have to decide on your quadrant. So sine is positive in the first quadrant and the second quadrant. So you are going to have q1 here and the second one here, and then we divide it. In the first quadrant, the answer to your solutions is going to be 2x is equals to 32.12 degrees plus k 360 degrees, because the period of a sine graph is 360 degrees. So then your x is going to be 16.06 degrees plus k 180 degrees, because we divided by 2, so everything gets divided by 2, even the period, obviously with k being the element of an integer. That's the first part of your solution. And then you come to your second quadrant. Remember, in the second quadrant is 180 degrees minus the reference angle, which is 32.12 degrees, plus k 360 degrees. So here your x will be what? Your x will be 73.94 degrees plus k 180 degrees, with k being the element of an integer. And then you now have your final two answers, and you've solved this given the general solution. Now let's look at the third example. Third example, you have cos y is equals to sine 2y. So in this case, I'll suggest that you change one of these things using a cofunction, and you make them the same trigonometrical function. So I'll change this cos y into a sin using the rules of cofunction. So this is the same as sine into 90 degrees minus y. Yes, that will give me cos y, and then it's equals to sine 2y this side. So since I have the same trigonometrical signs on both sides, I can drop them and leave whatever is inside the brackets. So what is inside the bracket is this 90 minus y and this 2y. So actually my reference angle here, my 2y, is equals to 90 degrees minus y. That's my reference angle. So then I check, where is the sine graph positive? The sine graph is positive where? In the first quadrant and in the second quadrant. So in the first quadrant, what do you have? I'll have 2y is equals to 90 degrees minus y plus k 360 degrees. Right? Therefore, if I were to solve this thing, I'll get what? 3y is equals to what? Just 90 degrees plus k 360 degrees. So my final answer is going to be y is equals to everything here divided by 3. I'll get the what? I'll get a 30 degrees plus the k 120 degrees. Obviously with k being an element of an integer. And then for the second quadrant, it's going to be 2y is equals to 180 minus my reference angle of what? Of 90 degrees minus y plus k 360 degrees. So if I were to simplify this thing, I'll get 2y is equals to 180 degrees minus 90 degrees plus y plus k 360 degrees. So this y will come this side, so this side I'll have only 1y. Therefore 1y is equals to 90 degrees plus k 360 degrees, with k being an element of an integer. And then there you have it. You have finally solved your trigonometrical general solution. That's it for today, guys. So if you appreciate the content, please comment, like, subscribe and share. Thank you.